Okay, we're coming to the end of this class. We are nearly there, understanding the the code that we saw in the beginning. But there's one last thing that we need to do, and this is creating reusable functions. This is again a core concept in programming that you should familiarize yourself with. And the problem is that if you write code the way we did until now, you have to write it again and again if you want to do different things. You cannot reuse it. It's difficult to maintain it if you want to change things and things like that. So one way of dealing with this is to use functions. And functions are basically a way of packaging code into distinct units, and then you can move these units around, reuse them, change them slightly, and give them a new name, so you have something a bit more manageable in your code. And this is a it's something when I started coding, I thought, oh, what is this for? And I kind of shied away from using it for a while, and but then you realize you have to sort of copy and paste code quite a lot and things like that, and eventually it became more natural now. Mostly, even if I only use it once, I prefer writing a function that separates concerns, and it makes it easier for me to come back and read that code as well. um, the main uh, so how this works is that you define what you want to do with these definition statements. You give the function a name, and similar to variables, the nomenclature is always everything is lowercase, and different words are connected with underscore. And so here we have a function molecular weight calculator, and then you have two parentheses, and everything that's in here are different variables, that different parameters that you add to the function. So this will be this you fill in different variables in here that will then be used by the function, and in the end the function chunks out what you want to do. So in a way you can view this as almost like a black box that takes your values, does something with it, and then throws out a result. And you've seen and used functions now, like for example, length is something like that. You put into the parentheses, you put the list, and then it gives you the length of the list out. So this is a typical function call, for example. The good thing is once you have that, you can actually do it again and again. So it's much easier to reuse it. You don't have to rewrite this again, many times. So you just call that function, and you provide it with the parameters. So here we have always the same weight, the same end concentration, and now we're using the different lists items. So in a way we are bypassing for loop here, but this is just one example, but we can actually use the function quite nicely within the for loop as well. And then we chunk out the result. So this is the first example. So let's dive. This is quite an important programming concept and an important part of Python to write proper function and to know about functions. So let's dive a little bit deeper into that. The Let's start with something very simple, which is a function that all it does is it takes some values and it prints them out, or it changes them a little bit and prints them out. So this is the example here. So you have calculate molarity. It takes two parameters, moles and volume liters, and then it does the calculation, and in the end it prints it out with a nice F string. So that's a very simple function. There's actually here this line here. This is a convention that it's called a doc string. This helps you remembering what the function actually does. And you put this with these triple quotes here, so you can actually write multi-line comments. This is the main reason for doing that. So you could say here what parameters you're using and things like that, but we are not bothered with that right now. Let's leave it like that. In this case, the name of the function should be chosen in a way that already explains what it does, but then you can provide more information on the function in this doc string. And for your own function, if you don't want to, you don't really need to. This is not a necessary thing you need to write here at all. But it's a conventional. It becomes quite useful when you write quite a lot of code. That again, it's a a memory device for you and for other people that read your code to understand what it is doing. Right. So this function run again, we put in these values. The function does its thing and then uh, outputs our print statement. Here now we're doing something a little bit more complicated. We are actually returning something. So this is take values in, process the values, put new values out. And in this case, a very similar function, but now after processing, we use this return statement here to return our calculated value. Okay, and when we run this function, so here we define some variables. Now we provide these variables as arguments to the function. And there's actually one important step. This function here now, it will return something. That means we need to bind this to a new variable. So we say here this NaCl molarity equals the result of this function, and the result will be returned here. So this is an important step that you have to realize, that when if you don't do this, nothing will happen. The function will run, but we're not catching the output of the function. We need to catch that into a into a variable. This will give us, it will actually print in this case, because it does actually in the end print out the variable. It will give us an output here, but normally this will be lost, as you can't reuse that. So you have to, in order to reuse it, you have to bind it to a new variable. Okay. Yeah, I think that's more or less everything I want. Oh, there's one more important thing. If you define new variables within the function, these will be lost later. Only what you return and bind to a new variable afterwards will be maintained in the code, will be remembered. This molarity here, for example, if we want to say print molarity, it will not remember that. Whereas within the function, it does remember it. So if we print this here, now it will remember it. It will print this out here, because this molarity variable is remembered within the scope of this function. So as long as the function is running, it remembers it. Once the function is returned, all of this stuff is deleted and it's not maintained in memory. So this caused me quite a lot of confusion when I started with programming. Is like, what does that actually, why is that value not there anymore? So I hope I explained that in a way that is understandable. I've given you quite a lot more information here. I'm aware that I'm overloading you. I do, but the reason for that is we only have 5 lectures, and I want to get you to interesting stuff. So you have the whole semester then to go through these things and practice them. But I'm front loading you with a lot of information. But I think with the help of large language models and with asking questions, you can actually acquire quite quickly proficiency, and then you can start doing interesting stuff, and that will make coding a lot more attractive for you. So I hope I'm not putting you off giving you so much information in the first lecture. Anyway, I think this is all I want to say for functions right now. There's a few more details on returning multiple variables and keyword arguments and things like that. You don't necessarily need to know that. If you're interested in read it through and do the exercises, and again, there is a functions notebook with a lot more information, so have a look at that. But I hope you got an idea of what functions are, or what is the meaning of functions now. And now we should be able to understand our code. So that's basically uh, where we want to get back at. So this is what we started off with. We have this molecular weight function. You see, it's very, very basic, but it took me about an hour to go through and explain you all these different things that are happening in this code. We have a function here that just does the very simple molecular weight calculation. So it takes the parameters in and chunks out the result of the calculation. We're running a for loop that now uses this function and generates the information that we need. And now we're printing this out in a nice f-string formatted um, print statement that gives us, our information. So we have sort of solved our problem. If you would want to use this in the real world, and we have really like hundreds or thousands or even hundreds of thousands of values. I mean, I hope nobody will have to do 100,000 lab stock reagents, but if we have a lot of values, we probably would want to use a file system and then read the file in. But going through that file import and output right now is probably too much. But if you want to set this program up on your computers and want to use it on a daily basis, we can talk in the lab about that as well. So just what you've learned, breaking it down, you've learned dealing with the data in lists, and then there's a function that does the actual heavy lifting calculation, and the for loop that processes this again and again. So I think you've done an awful lot of learning in this session. So this is a real sort of jump in the deep water straight away to make you learn how to swim. But yeah, congratulations to make it through. I think we've covered some of the core concept of the Python programming language, and you can immediately apply that to various calculations and set up automation in the lab. In the next lecture, we'll talk about DNA strings and how to deal with DNA, because this is one of the specific data types in biology, and there's a lot of nice tricks and a lot of nice, it's a really nice way of learning how to code and learning some basic concepts, but also doing something that's very biology specific.